Continuing on with part 2, which is hypothesis testing for means, we're going to work on finding the p-value. So first I'm going to show you kind of what's actually happening graphically with this as we've been learning about. So our test statistic is negative 0.94, very close to negative 1. That refers to the number of standard deviations away from the mean our value is. So if I were to draw this distribution, our mean, our population mean would be in the middle, again, what we assume to be true. And what we're saying is that our sample mean is a standard deviation or close to a standard deviation below the mean. If we're using the standard normal distribution of z-scores, our z-score is negative 0.94, I believe. Yes. So what we're saying is this is where x bar is. This is where mu is. So our test statistic is telling us how far away are we from our population mean or assumed population mean. Now, when we're looking for the p-value, part of this has to come from what tail we're working in. So here we have a less than sign. So in this case, we have a left-tailed test, and we need to find the area to the left of this value. So again, less than in the alternative implies we're doing a left-tailed test. If it were greater than, then it would be a right-tailed test. If it were not equal to, it would be a two-tailed test. But in this case, we're looking for the area to the left of this test statistic. Again, that's because this says less than and because our sign in the alternative is less than. Okay, so when we do this, the p-value, area with our t-distribution, as we've been learning about in our modules, we can use t.dist in the same way that we can use the norm.s.dist. So t.dist, again, we're using the t-distribution because we have means with an unknown population standard deviation. We have a sample standard deviation. We calculated that, but that's why we're using a t-distribution and a t-score for our test statistic. So we need to use the t.dist function, which finds the area to the left of a value. Remember, this has to take exact values, so you cannot type negative 0.94. You absolutely have to click on this cell because the test statistic is not exactly negative 0.94. This is a rounded value. Or I should say the cell makes it appear to be rounded, but when you click, it grabs the entire number. Okay, so we have that. And then we have 30 is our degrees of freedom. Again, for that, you could just type it because that is exact, but I will click on it because I think it's good to train ourselves to reference other cells in Excel. Here you will put 1. Cumulative really is saying you're adding up all the area to the left of that value. Okay, so the p-value, again, we're finding the area to the left of our test statistic here. And because it's to the left, we don't have to do 1 minus. That would find the area to the right of something. So we can leave it like this. Okay, so we get 0.18. If I scroll down, let's check to see. And it did go up. So our score is increasing, which means that was correct. Okay, so now we have the significance level and the p-value. To make our decision with hypothesis testing, remember we need to compare these two things. So if the p-value is less than alpha, or the significance level, that means, I'm going to come over here. If the p-value were less than, again, this is the p-value. This area in here is the p-value. If this were less than alpha, that means alpha is larger, which means it would like cut over further in this area. That's not the case here. What we have is that our alpha, I'm going to use a different color here, our alpha is less. So alpha is 0.05. Our p-value is 0.18. So because that area is less than, what we're talking about over here is like alpha kind of tells us our rejection region is what we call it. So if our test statistic falls within our rejection region, then we reject the null. If it doesn't, then we fail to reject the null. In this case, because the p-value is greater than alpha, that means we are outside of that rejection region, which means we failed to reject. So again, because our p-value is greater than that cutoff, we failed to reject. Let's make sure that our score increased. And it did increase. It's up to 44, about 44% now. Okay, so coming back up, we just selected, we failed to reject the null. Our null is that the population mean number of words per day spoken by women is about 16,000. So basically what happens here is our test statistic was not super, super extreme. If we had a situation where our test statistic was very extreme, which would make our p-value very, very small, what's happening is we're saying that can't just like randomly happen, that we get a sample that is random and representative of the population, and we get a sample mean very far away from this value. If that happens, we start questioning how real this value itself is. But in this case, our sample mean is close enough to this value that we're not questioning it, and so we don't really have enough information to say that it cannot be 16,000. So here our conclusion: if we fail to reject the null, we don't have enough information or evidence to support the idea that women speak less than 16,000 words per day. Okay, let's go check to make sure that is the correct interpretation, and it is. And yours, and we'll be done with this video now before we move on to part 3, but in your version of this, again, you might have a different decision to make based on your p-value, based on your test statistic, but I wanted to kind of walk through the interpretation of one of these verbally with you, because I know you've been watching other videos of other people explaining hypothesis testing, but I wanted to explain it as well. So please watch that interpretation part several times if you need to. It really can help your understanding of what we're actually doing here. Again, I've brought up the idea of a rejection region, which is where alpha falls. And so if your test statistic falls in that rejection region, we're saying that is so far away from that claimed population mean that we question whether that's even true or not. In this case, that's not far enough away for us to question that value. Cool. All right. We'll be back in the next video to talk about confidence intervals and hypothesis testing for proportions in part 3.